Welcome to the exciting world of computer engineering. This field merges the principles of electrical engineering and computer science, providing the foundation for designing and developing computer systems and other technological devices. This chapter will give you an overview of the various fields within computer engineering and introduce some fundamental concepts. Computer engineering is a broad discipline that encompasses several specialized fields. In this chapter, we will explore key areas such as computer architecture, embedded systems, VLSI design, software engineering, networking, cybersecurity, and robotics. Computer architecture involves the design and organization of a computer's core components, including the central processing unit, memory, and input-output systems. It focuses on optimizing the performance, efficiency, and cost of these components. For example, designing a new CPU that can execute more instructions per second to improve the performance of a computer system is a key aspect of computer architecture. Embedded systems are specialized computing systems that perform dedicated functions within larger mechanical or electrical systems. These systems are often embedded as part of a complete device, including hardware and mechanical parts. For example, the microcontroller in a washing machine that controls the washing cycles and water temperature is an embedded system. Very large-scale integration, or VLSI design, involves creating integrated circuits by combining thousands or millions of transistors into a single chip. This field focuses on the design, testing, and manufacturing of these chips. For example, designing a microprocessor chip used in smartphones is a key application of VLSI design. Software engineering is the application of engineering principles to software development. It involves designing, developing, testing, and maintaining software systems. For example, developing an operating system that manages hardware resources and provides services for application software is a key task in software engineering. Networking involves the design and management of computer networks, including local area networks, wide area networks, and the Internet. This field focuses on ensuring reliable and efficient data communication between devices. For example, designing a network architecture for a large corporation to ensure secure and efficient communication between different departments is a key aspect of networking. Cybersecurity focuses on protecting computer systems, networks, and data from unauthorized access, attacks, and damage. This field involves implementing security measures and protocols to safeguard information. For example, developing encryption algorithms to secure online transactions is a crucial task in cybersecurity. Robotics combines computer engineering with mechanical engineering to design and build robots. This field involves creating both the hardware and software that allow robots to perform tasks autonomously or semi-autonomously. For example, designing a robotic arm for use in manufacturing assembly lines is a key application of robotics. To excel in computer engineering, it's essential to understand some fundamental concepts such as the binary number system, logic gates, Boolean algebra, microprocessors, memory, and communication protocols. Computers use the binary number system, which consists of only two digits, 0 and 1. Each binary digit, or bit, represents a power of 2. For example, the binary number 1011 represents 1 times 2 to the power of 3, plus 0 times 2 to the power of 2, plus 1 times 2 to the power of 1, plus 1 times 2 to the power of 0, which equals 8, plus 0, plus 2 plus 1, resulting in 11. Logic gates are the basic building blocks of digital circuits. They perform logical operations on one or more binary inputs to produce a single binary output. For example, an AND gate outputs 1 only if both its inputs are 1. Boolean algebra is a mathematical framework for analyzing and simplifying digital circuits. It uses binary variables and logical operations to represent and manipulate logical expressions. For example, the Boolean expression for an AND gate with inputs A and B is A dot B. A microprocessor is the central unit of a computer system that performs arithmetic and logical operations. It fetches, decodes, and executes instructions stored in memory. For example, the Intel Core i7 is a widely used microprocessor in personal computers. Memory in a computer system is used to store data and instructions. It can be classified into primary memory, such as RAM and ROM, and secondary memory, such as hard drives and SSDs. For example, random access memory, or RAM, is used to store data temporarily while the computer is running. Communication protocols define the rules for data exchange between devices in a network. They ensure that data is transmitted accurately and efficiently. For example, the Transmission Control Protocol, or TCP, is used for reliable data transmission over the Internet. Computer engineering is a diverse and dynamic field that plays a crucial role in the advancement of technology. By understanding the various fields and fundamental concepts, you will be well equipped to embark on your journey as a computer engineer. Stay curious, keep learning, and embrace the challenges and opportunities that come your way.